the main goal is to make something simpler and cheaper than what I had been working on, and I am still working on the old one. But with cheaper comes some trade-offs. One of the trade-offs here is going to be overall reliability. So on the previous turrets, the main drivers were long-term reliability. So all of the wiring and cables and slip rings were housed inside of a giant cast iron housing. But now you're going to have cables that run from your motor pod down to an electronics pod. This pod will be enclosed. And what that's going to look like in real life is these are the motors I'm using. One of the other big trade-offs here is that in other designs, I had built my own motor, gearbox, and encoder, and that allows you to use a lot more common parts. I could use common stepper motors, but here I'm using a very specialized part. It's very expensive. This is $300. I can't find them cheaper, but it does everything for you. There's power and communications, and it does all the encoder, the gearbox. It's small. What this small size allows is now this thing is like a sort of backpackable solution. But the wires for it, the cables, are just going to be external to the the turret. And that's bad for a lot of reasons. They can get hit by shrapnel. But the idea is to build it like a modern drone, where the cables are just kind of zip-tied and glued onto the thing. Another thing that changes is instead of having metal castings, there's really only a couple main hard-to-manufacture parts. The first is this bent metal bracket. There's another bent metal bracket. There are 2 aluminum plates that hold a bushing in place. There is another metal plate that holds the Picatinny rail clamp. And other than that, it's mostly 3D printed parts, aside from one little easy to make part on a lathe. So I'll show you how I plan to put that stack together. So how this would go is, this is your main cut metal bracket, and I was able to get these for $37 a piece from Send Cut Send. These are your 2 metal plates that basically just hold a bushing in place. Now, I found a few things off the shelf that were just about right, but everything would have made this clunkier, and I see just a little bit more of a future in doing things this way, because these are easy to repair. So we'll see how that turns out. Maybe I'll go back on that design decision. The other thing is, it just looks a hell of a lot cooler when you have these, matching diameter parts. Looks a little more badass, and I think that's kind of part of this, is it has to look good. So how this stack up is going to work is you'll start with a motor. Let's see. Then you'll place this bracket on here, and you'll line up these holes here. Whoop. And then you will take your machined part, and I found a source for these at quantity 10. They were about $30 a piece. I'm sure if you're ordering thousands, it would be quite a bit cheaper. So this will have 6 M3 holes into it, and you will screw this into the drive shaft of the motor assembly. So this will go in here, and this cylinder will spin. There will be a spline in there, and I may have to make this out of steel. This one's made out of aluminum, just so it's a little easier to machine. And then you'll take your laser cut. I call this the bushing standoff. Then this is the bushing holder. That bushing would press into this. And my first guess with this laser cut plate, the bushing actually pressed in there fairly easily. So my goal is to be able to sell some of these parts so that somebody with a file and just really basic hand tools like a file, a drill, can put this thing together. Of course, if you have a lathe, if you have all this other stuff, you can really probably just buy like a couple of these basic parts if you wanted to, and do the rest yourself. The idea is to really split this up as a kit, so you buy what you want depending on what tools you have. So once you have this, you'll put bushing in there, and then to attach to your airsoft deal, that will need to get filed out just a little bit. It's actually my first guess with the laser cutting tolerances, and it almost presses on there. Like, I think if you put your mind to it, you could probably make that work. Then this Picatinny rail clamp will go on here, and so that is sort of this area, clamp on here. The bottom is identical, except that exact same plate here that clamps onto the pick rail now clamps onto this bracket. And so this bracket is a 1/4 inch thick. This is just under a 1/4 inch. If this is not quite stout enough, I'll increase the size. But honestly, it feels pretty stiff. I might go down in size on both of these just to lighten this thing up. I really want something that you could take, backpacking, or, take it out on your quad, cut off a little tree and screw it into a tree. Just kind of a nice quick setup. So the other major element of this is the electronics. And on the electronics, I'm going to go pretty cheap to, again, make this thing inexpensive. I'm aiming for $1,400, which I know is a lot of money, but that's for low quantities. The more of these we can make, the better off we'll be. So it'll be a Raspberry Pi 5 to start with. This is a CAN shield, so these motors run off of CAN. And then you'll also have a 48 volt to 12 volt converter. So backing up a little bit, the main things that go into this Sentry turret are 48 volts and hardwired Ethernet. You can put Wi-Fi on it if you want, but that's not my style. So you'll have 48 volts and Ethernet coming in here, 48 to 12 converter, a 12 to 5 converter to power the Pi. The 12 volts will power your, accessories. You can also, I'll have two 12 volt ports, so you can power this accessory, and you can power a roughly 100 watt light, which, if you're familiar with 100 watt LEDs these days, they will incapacitate you. I mean, if you were trying to shoot your airsoft at this thing and it was blazing a 100 watt LED in your face, your eyes would be hurting. It would, you might be able to shoot in the right direction of it, but you are at a severe disadvantage, and there's things you can do with the frequency and blinking the light on and off that will severely mess with people's minds as they are trying to look at this thing. What else do we have here? So yeah, we'll start with a Raspberry Pi. This electronics box will be held on by this funny little plate, and this plate will have, what's the best way to show this? Two little holes here, and I will have to revise this to bring these holes down a little bit. When I added these covers, they got a little bigger. They got a little bigger than I wanted because I added some cooling. But there will be a small bolt that goes through here and some rubber bushings. Those rubber bushings will allow this assembly to jostle and vibrate. Essentially what it'll look like is in the back here, there will be some connectors and some wires dangling off your turret. So if your electronics get damaged, you'll be able to pull this unit off with just two bolts, just undo all the connections and bolt a new one on. It will also mean it'll also mean you'll be able to upgrade to more powerful compute modules. They might take up a little more space, use a little more power, but these are going to be really powerful, and we're about to see an explosion in the next who knows how many years of we aren't going to be talking about calibers and bullets and grenades. We're going to be talking about processing power, and shielding, and thermal visual shielding. That's going to be the real thing in the future. The future's computation is going to be a big part of airsoft. So the final thing on here is you'll notice these kind of slots, and I've spent quite a bit of my time now. Well, not a lot of time, but time in terms of calendar, but not really a lot of hours spent on figuring out armor for these things. So what I've come up with is these armored plates that you can put on and off with some pins. The little angled plates will be the same thing. I don't think I have it modeled very well here, but these would also be tabs that you could put pins in, and that would allow you to essentially pin on a lot of different configurations of armor. You can see there's some gaps here. So you could actually put like 1/2-inch AR 500 on here if you wanted. You could put nothing. You could put thermal camouflage. You could put thermal distractions. You can pin on a lot of different accessories here. Maybe you'd pin on a cold weather, I don't know, enclosure or something like that. But the general idea here is just this pin on armor. And yeah, when this thing gets shot, these pins are going to get ripped up. If you're, worried about something coming at you from above, this armor covers a lot. Not everything, but you can just imagine all the different shapes you could cut out here, and you could add stuff to the sides. I'm just kind of trying to leave it configurable for now. Let's see, is there anything else going on here? I think I'll just spin it around a couple times. Give you an idea of what I'm working on. So that's the update for now. I'm personally in life, it's a little bit hard to get to a machining shop right now, just because of where I'm at. So it's going to take me a bit to get all this assembled up. I need to widen out a couple of these holes and widen these things out. So a few little things before I can get this assembled. But I have code that should work. I'm trying out some new code with something called ROS 2, and that will really make all the code a lot simpler to simpler to add like whole new turrets as modular items. So ROS is robot operating system, which I'm trying to copy and paste these turrets. Computer's freaking out. So that essentially ROS, you can make each element into a little node and put the nodes together in a robot. And my idea is these robots will be nodes on your property, and you could have multiple turrets working together on your property to achieve your goals. Because the cool thing about this design, even though it's kind of hacky compared to what I've been working on, is that these motors are manufactured in a lot of different sizes. So some of them are almost like 6 times the power. And so once you have the concept down, a lot, the compute will be the same. A lot of these parts are pretty simple. I mean, this all took me, maybe 2 or 3 days of actual CAD time to do all this. So in 2 or 3 days, you could crank out a bigger design, and it'll just cost more, but not be any harder to manufacture, any harder to source in terms of supply chain. yeah, so that's the latest update. It's so cool hearing all your guys' comments, and keep them coming. This is a ton of fun working on this stuff. I'm really excited to get this guy out and test it, and I will definitely have armor testing videos and shooting this thing and this thing with an airsoft shooting at me, and we're gonna have a lot of fun. So thanks for watching.